Welcome to Pratham Science Academy classes, and in this video we are about to learn or discuss what is inertia and how this is applicable in Newton's first law of motion. So what is inertia? So this inertia is, we know that, okay, before that, let's say we have this object which is at rest. Now, this object will continue to be at rest unless and until some external force is applied on it. So if we push this object, it may move or will try to move or will try to move in the direction in which the force is applied. And let's say there is a moving object, let's say this car. Now this car is in motion and it will continue to be in motion unless we apply brakes and the friction. If this is the moving direction, then the friction acts in the opposite direction that stops the car. So in both these cases, this object will continue to be in rest unless some external force is applied. And this object will continue to be in motion unless this force of friction acts in the opposite direction. And let's say an object, let's say this ball, it's moving in this direction and we hit it from this side with a bat, and now it changes its direction to this side. So it will continue to move in the same direction unless we apply this external force and change its direction. So what we have learned here, that there is in all these cases there is a property, so which is called inertia. So inertia is a property which is inherent in all those objects. So it is a property by which an object, or which we can say it is a property because of which or due to which an object will remain at rest or continue to be in motion or will continue to move in same direction. And this is happening till unless some external force is applied on it. Okay, so inertia is the property due to which an object will remain at rest or will continue to be in motion or will continue to move in the same direction unless and until some external force is applied on it. So this property of an object is called inertia, and we have the three types of inertia. That is the inertia of rest. So the property which keeps an object at rest unless some external force is applied is called inertia of rest. And the property which keeps an object in motion unless some external force is applied on it is called inertia of motion. And third one is the inertia of direction. So that an object will continue to move in a particular direction unless some external force is applied on it to change the direction. So we have three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Now let's consider some daily examples where these inertia is applicable, or we can find the use of the inertia. The first one is when car suddenly stops or starts, passenger moves backwards. So the first we can say the application is when car, and we will see what type of inertia it is, the first one, the second one, or the third one. So the when car suddenly starts, you might have experienced it that we fall backward. So when car or the bus suddenly starts, passenger fall backwards. So why is it so, and or what is the reason for this? So when the car suddenly starts, let's say this is a car and the passenger is sitting in the car. Let's say this is the lower part of the passenger or lower part of the body. Now, when the car suddenly starts, the lower part of the passenger is in contact with the floor of the car. So, due to inertia of motion, this or when the car starts, this part, the lower part will come in motion as it is in contact with the floor of the car, but the upper part will continue to be in rest because of inertia of rest, and hence we fall backwards. So that is the reason. So we can say that when car suddenly starts, the lower part of the body. So when car suddenly starts, we can say the lower part of body which is in contact with the car comes in motion, which is in contact with car, it comes in motion. But the upper part, it will continue to be in rest because of inertia. And hence we can say that hence we fall backwards. So this is, in this case, we have to mention that this is because of inertia that we fall backwards. So the next example is when the brakes are applied, passengers are pushed forward. So this is the first example, first application, or let's say the use of inertia. And the second one is when car or bus brakes are applied, let's say the bus. So when the bus brakes are applied, passengers fall forward or get pushed forward. So in this case, it's the same reason. Let's say this is the lower part of the bus where the passenger is in contact with the lower part, the lower body. This is the lower body, the lower part of the body, and this is, let's say, the upper part. Now, when the brakes are applied, because the lower part is in contact with the floor of the bus, this part will come to rest, but this will continue to be in motion, hence we fall forward. So this is because of the inertia as well. So we can write here, or we can give the explanation that when car or bus suddenly stops, the lower part which is in contact with the bus, this comes to rest. But due to inertia of motion, this upper part of our body, it continues to be in motion, hence we fall forward or we are pushed forward. So this is because if we fall forward. Now next, very good example would be when we beat a hanging carpet with a stick, dust falls off. So what is the reason for that? So this could be the third case, and we can say that when this hanging carpet is beaten with stick, dust falls off. So what is the reason? Okay, let's say this is the carpet and we have dust on this. So when we beat the carpet with a stick, so this is pushed backward. But because of inertia, the dust particles will continue to be in rest, and hence they fall downward. So this is the reason when the carpet is beaten, which comes in motion. So let's say when carpet is beaten, this is the reason it comes in motion, but the particles are at rest because of inertia. And hence the dust falls off due to gravity. It will fall downward due to gravity, will not go upwards. The dust falls off, or let's say downwards. So because of the force of gravity. So this is what is inertia, and these are the very convenient examples that we can show off. And one example more we can cite here is when a tree is shaken vigorously. Its fruits or leaves they fall down. The reason here is same. When a tree is shaken vigorously, its fruits and the leaves they fall down. The reason for that is when a tree is shaken, it comes in motion. And when the tree comes in motion, but still the fruits and leaves they remain at rest due to inertia, but leaves and fruits. So this is how you have to write an answer for this. Make sure to mention due to inertia in the answer, and thus they fall off, fall down to the ground because fall off due to, and the reason here is due to gravity. So we can explain this. Okay, some more examples we can also uh, give here for the inertia is that when a car takes a sharp turn, we tend to fall sideways. So this is one more example which can be asked for the reason. So when a car or bus that takes a sharp turn, we fall sideways. So okay, let's say this is a sharp turn and we are in this car. Let's say this is the car and we are sitting here. The car comes here and we fall sideways towards this side. So that is also because of the inertia. And the reason is that when the car or bus takes a sharp turn, the lower part of the body, which is in contact with the car, also takes a sharp turn. So here, the lower part, which is in contact with This is the lower part of body which is in contact with lower part of car or bus. This also takes sharp turn. So because the car or the bus is taking a sharp turn, our lower part of the body will also take the sharp turn, but upper part is still moving in a straight line. Or we can say that upper part continues to be in a straight line, and this is because of inertia. So upper part continues to be in straight line due to inertia, and hence we, or let's say the passenger, they fall sideways. This is how you can explain the reason for this. And we can also get one more example for this, that is, it is dangerous to jump out of a moving bus. Why? So this, it is dangerous to jump out of a moving bus. And what is the reason for this? So let's see, these are six use of the inertia or the application of the inertia. So why it is dangerous? Okay, let's say this is the bus which is moving, and suppose this is the passenger. So when if the bus is in motion, so this passenger is also in motion when he jumps out of the bus, and let's say he falls on the ground. Now the ground is in rest, it's at rest, and as soon as his lower body touches the ground, the lower body comes to rest, but the upper part still continues to be in motion, and hence we fall. So, and may get hurt. So that's why it's dangerous to jump out of a moving bus. And the reason we have mentioned here is that when we jump from a moving bus, so when we jump, so our feet comes in touch with the ground at rest, but our upper body, it continues to be in motion, and hence we may fall on the ground and get hurt. Hence, you can see that. Okay, so these are some of the applications or the reasons where we can cite examples for the different types of inertia. So by this time, we are clear that what is inertia and how this plays an important role in our day-to-day life for some of the applications. Okay, now which objects will have more inertia, the heavy one or the light one? Let's try to make. So now the question arises, which object? So which object had more inertia, the heavy or the lighter one? Okay, so in this case, more is the mass, more is the inertia. So heavy objects have more inertia than lighter objects because let's say we have two objects, one of mass 30 kg and one of mass 10 kg. So it would be difficult for us to move an object with more mass. So more is the mass. It's difficult to move this object. So that means that it will tend to remain in rest. So that means the more will be the inertia. So Heavier objects, more is the mass, more is the inertia. So heavy objects have more inertia than lighter objects. So we can say that more is the mass, more is the inertia. Or we can say that mass is the measure of inertia. Inertia, sorry. Okay, so mass is the measure of inertia, more is the mass, more is the inertia, and with this we are done with the with today's topic for inertia and its types. Let's move on to the next topic. Thank you for watching.